everyone. Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome Anand Kannappan, co-founder of Patronus AI. Patronus AI is one of the most innovative companies out there working on observability and evaluation for agents and AI systems. They have an amazing platform. They've created 2 custom LLM-as-Judge models, Lynx and Glider, and I couldn't be more excited about the launch of Percival. Anand, thank you so much for joining the podcast.
Thanks so much for having me, Connor. Super excited.
Awesome. So I'd love to just dive into what's new, the launch of Percival. Could you describe what it is and how it's changing the game for developing agents?
Yeah, so Percival is a highly intelligent AI companion of Patronus. It can actually detect 60 different kinds of failure modes, especially with agent-native failures like tool calling failures, context misunderstanding, agent planning errors, and there's a whole taxonomy that really describes this in much more depth. You can think of Percival as your best AI debugger that has spent thousands of hours understanding your domain and processing millions of tokens through that. And so, really excited about what Percival really means for not just the future of evaluation, but really the future of agentic supervision. And so, agentic supervision is this concept that we're really excited about and really see as a big part of not just our vision, but really where we see the world going.
Yeah, and I want to give a huge thank you to the Patronus team for letting me test out Percival before diving in. And yeah, it's such a cool thing. It kind of reminds me of the first time. I want to compare it to the first time I used Cursor and how it can edit your code for you, the way that I can develop an agent and have it debug the trace and then suggest all these different reasons it went wrong. I love the prompt fix. Yeah, just so many cool things. So the first thing I really just want to dive into this like agent debugging co-pilot and maybe just touch on the state of how people are developing agents. I know with how I'm personally working, I'm doing a lot of stitching together some concept of an agent workflow I think might work. How do you think about the current state of developing agents?
Yeah, absolutely. I'd say it's been really exciting what's been happening over the last few months, especially since last fall, in terms of the pace at which a lot of new companies are building agents, and we're seeing that happen not just with new AI startups, but even with largest enterprises in the world, where even their own architectures and their own stack is evolving, so that they are starting to think about how they build more autonomous systems from day one. And so of course, we've seen a lot of different kinds of frameworks that have evolved over time, whether it's Crew AI or LangGraph or Pedantic. And so, really excited about what the future holds for how people will build agents. But we're also seeing that, apart from just the framework itself, it's even just the problems that they're really trying to solve with agents is in many cases fundamentally new, and fundamentally they're rethinking. Companies are rethinking what it means to solve a problem for their own customers, what it means, for the structure of their own team in terms of who focuses on what and what areas can productivity really be accelerated. And so, really thrilled about all of that in general. And I'd say, especially with the advent of agents, there's a number of different new challenges in terms of what that means for the world, and those are exactly the kinds of things that would love to be able to double click into and share more about how we think about them and where we see the world going across them.
Yeah, awesome. So, I think definitely a lot that we can unpack with that, like kind of domain expertise and coming back to that topic. But I think there's maybe we could start with like understanding the common failure modes and maybe kind of the domain expertise that maybe like we have, so to say, is kind of like AI engineers, AI entrepreneur, like you more so than me, but like building these AI companies and like kind of we have this expertise of how to build agents. And I think that's kind of what is built into Percival is you have this knowledge of like, common failure modes, like whether it's a failure in the tool call, the LLM isn't picking the right tool, and just if we could maybe break into like the priors that you've cooked into Percival on understanding the common ways that agents fail.
Yeah, absolutely. So I'd say to take a step back, I'd say there's actually three. So when we first kind of mapped out where the world is going, what are our customers doing today, and where do we think they'll be in the future, we really identified three really big problems in terms of how AI workflows are evolving and why is it becoming almost near impossible to evaluate them. And so the first problem is context explosion, where we're starting to see AI systems, especially agentic systems, process up to tens of millions of tokens that are spanning lots of internal documents, external API tools, and different kinds of tools in general, lots of user interactions. And so all of this put together is just far exceeding the length of LLM context windows. In addition to that, agent actions are sequential and order dependent. And so, this idea of long range temporal data is just really introducing another layer of complexity. And then there's the second problem, which you mentioned, which is really around domain adaptation. And so I'd say generally everyone agrees that human in the loop is really important, and subject matter experts really play a big role in how AI products really turn out. And especially at the same time when we understand that systems are becoming increasingly autonomous, it does mean that now agents might actually have to become subject matter experts as much as possible themselves. And so we want to make sure that the problem of evaluation and oversight is one where it's not a one size fits all problem, but it's one that is very domain adaptive. And so that kind of leads me to the third and final problem, which I'd say is the biggest problem, which is related to uh, multi agent orchestration. And so this is really key because uh, when let's say the generative AI era really started to take off in 2023, we were talking about just LLMs in isolation. Then it was about LLM systems like RAG applications. Then it was agentic systems, which could still be, of course, with RAG in perspective, but generally just a more complex system. And now the future is about multi-agent systems. And so in that world, agents are calling other agents, and we're really starting to see that it's really hard to predict what agent trajectories or what systems will actually look like. And so it means that the traditional way of defining an evaluation or defining a unit test in a very kind of static approach or static data set is just practically impossible and doesn't make sense for the future. And so we just strongly believe that the right way to evaluate is to do it dynamically in the future, especially where we're dealing with multi-agent systems. And so that's why what we talk about at Patronus is the next phase of evaluation observability is actually supervision and oversight. It's more of a hands-on approach towards more of a slightly hands-off approach. But that's really how we feel in terms of the evolution of multi-agent systems, and that's of course a completely new challenge that requires a completely new way of approaching the problem. And so those are the three big things that led to why we started to develop Percival. And so Percival is extremely good at being able to identify different kinds of failures that fall into those kinds of categories. It's also really good at dealing with really long context, and it's also domain adaptive. And so we can dive into a bit more on how it's domain adaptive, especially with how we've thought through memory infrastructure and things like that. But our goal with Percival is really to solve those three big problems for all AI workflows for the future.
Yeah, I think with picking my next question, if I'm trying to appeal the most to the kind of most of the AI developers, I think I'd go for sort of how you think about the context window, maybe like points 1 and 2. But just as more of an AI researcher, I just have to pick my own interest in this last concept about dynamic evaluation. Can you just maybe open up that further? What you mean by that and the vision there?
Absolutely. So I'd say the contrast that I make is actually with what I would describe as static evaluation, where static evaluation is one where how I'd say most companies, whether it's software or more specifically AI products, most companies are approaching, where you develop, you create some kind of a data set, you come up with examples in the data set. It could be examples you've generated, or a human has constructed them in some way. And this could be a set of 50, 100, 1,000, tens of thousands of examples. And if it's something that is very domain specific, something you develop internally, maybe it's a evaluation data set, or perhaps it's some kind of a benchmark that you're using just to understand how to perform, just to understand how the system actually performs. But anytime you have a single kind of data set or benchmark, by definition, it's static. It's a one time way to really approach how to measure performance of a system, and that might work. Obviously that works well for software that is rigid and stable, and it's something that customers interact with. It can also potentially work well with language models that have been trained, and they're available to use out of the box, whether it's through an API or through open source. But the moment we start talking about agentic systems, it means that now these are to some level living, breathing organisms that are actually dynamically evolving. They are interacting with other agents, or interacting with other stimuli. They are living in environments that are, in some ways hard to potentially predict what might happen in a particular trajectory. And I'd say the more complex these systems become, where we're dealing with teams of agents or organizations of agents, it starts to become more challenging to really even be able to predefine or even define a static type of data set that even makes sense. Because there's no way to properly really think about what the true actually looks like. And so, what dynamic evaluation really means here is there a way for a separate, equally capable, highly intelligent system or agent or set of agents that can themselves evaluate the agents in question? And so that means that the ways that we evaluate actually has to also evolve in the same kinds of ways. They also have to move. And so that's really what we believe at Patronus is really the future of scalable oversight, is this idea that we will in the future live in a world where humans can no longer scalably have oversight over AI. And so we need to live in a world where equally capable, intelligent AI oversee AI. And so that's really how we believe dynamic evaluation is going to play a really big role. If we talk more concretely about agentic systems and how that falls into dynamic evaluation, I would say at Patronus, we think about it in two types of ways. There's this idea of process rewards and then this idea of outcome rewards. And so with process rewards, you're really looking at what are agents doing step by step in the trajectory within the system, and how do we make sure that those kinds of things have the right kind of supervision. And then there's outcome rewards, which is did the kind of overall agent or system actually perform in the way that you wanted by the end of it? What was the outcome? And so ultimately, we believe that both of those things really matter. And so those are the kinds of things that play into how we think about dynamic evaluation methods and where the future of this really stands in over time.
Yeah, I think maybe this. I really like this delineation of process rewards versus outcome rewards. I think maybe it depends a little bit on your perspective of agents and how sort of like autonomously you're building your agents. Like with Weaviate, with some of our agents that we've released, we kind of evaluate them maybe as like a process reward in the sense that we like decompose it into several inferences and the kind of like compound AI system view of thinking about it. And so we have like kind of yeah static eval sets for each of the steps of this, but already our static eval sets are taking this like generative approach where a lot of AI agents are helping us design our sets and so we're already pretty mature on that one. But then this kind of outcome rewards and I guess like I'm still kind of trying to imagine these systems. I guess like if it's an open-ended autonomous agent and it does like yeah, I guess really open-ended tasks. Now you've got this dynamic environment. Yeah, yeah. So I think I'm starting to wrap my head around it, this kind of idea of having like an environment to evaluate an agent, but it still definitely seems like yeah, I'm trying to just understand like if this matters on how open-ended you're defining your agent, and maybe we could zoom into an example. Like let's say we have an agent that writes. Okay, so I think this is the example I'd want to zoom into. Is it an agent that say writes a blog post? It's going to take this podcast transcription and it's going to turn it into a blog post, and that's sort of something that's maybe a little. Would you see that as like a traditional agent, whereas something that's more like it's just like a podcast marketing agent, like it broadly does tasks. Maybe it turns us into a blog post, whatever it thinks is going to spread the podcast the most. Is that maybe the right way of thinking about it? Is like what kind of agent are you building? Yeah.
Yeah, absolutely. Yeah, I'd say I think the degree to which it's open ended certainly plays a role in how, let's say, how hard it is to like statically evaluate something. And so I think with a much more simpler system, more simpler agent where maybe you have a few different LM calls and maybe it has to make fewer decisions and the decisions are much more simple. Then in those kinds of cases, it may be very well possible to evaluate something statically. I'd say the outcome rewards piece, or sort of like the end to end type of evaluation specifically, especially in those kinds of scenarios, can be done more simply. And so for example, let's just say the outcome is, let's just say you want to make sure that that the agent, let's say books a flight. I think the quintessential example of an agent is can you get it to like book a flight for you? And if it actually books a flight by the end of it, and it falls within the parameters of what the initial query was, then you could say that that's great. But if let's say it's a bit more open ended, like you said, let's say we ask an agent to market the like a product launch, and we don't really give it any other specific kinds of requests. You don't really say go write a blog or go interview someone on a podcast or talk to the media. But if you just let it kind of approach it and make its own decisions and in its own kind of autonomous way, then I'd say those are scenarios where it becomes pretty hard to statically define something, statically define evaluation beforehand, because uh, you may not be able to, for example, understand what whether it used the right tools or talked to the right people or um, approached something in the right kind of format, just because there's just so many there's so many possible avenues or possible paths that the agent could actually take to accomplish something. And so I think especially for areas where trajectories are hard to predict ahead of time, it's really hard to be able to optimize for process rewards unless you potentially have a dynamic way to actually evaluate.
Yeah, super cool. Yeah, I guess there's something about the dynamic thing that reminds me of like these environments. Like obviously, like there was like reinforcement learning's early days with OpenAI's bipedal walking agent, and you had this whole like physics simulator of controlling a robot to walk, and that's where you kind of like have this like environment, or maybe like you're tuning a database system, and there are papers like Database Gym, and that's kind of maybe one way I think about these things is you build this like constrained world for the agent to operate in. Yeah, kind of maybe coming back to Patronus. Another question I wanted to ask about the kind of use of Percival that this kind of like static versus dynamic evaluation is inspiring me to think about is like coupling Percival with kind of the traces. Like we have like with these observability platforms, it's a lot of it is you're logging all your calls in production or development and so on into like you know these observability platforms compared to kind of this other thing that's emerging, which is you have your static eval set and you run your inferences, and the observability platform is kind of helping you that way. So I guess maybe my question is, which of those two do you see is the most common use of Percival, like production traces, or maybe like eval sets? Yeah,
Yeah, absolutely. So I'd say for the first version of Percival, I'd say it's more useful as an ability to actually understand uh, traces that were actually run, and those traces could be from runs in development and testing, or it could be in production as well. But as soon as you actually have, let's say, run your agent against particular kind of workflow, against potentially a set of documents or whatever the kind of setup might be, you then suddenly might have a ton of data in terms of what the agent actually did and what happened. But this might be really long context. There might be different kinds of data structures. You might be dealing with different kinds of tools, and so trying to step through every single piece of that kind of directory could be really challenging. And we've seen, as we've worked with customers, that in some cases they spend hours trying to just interpret a few different traces. And in order for them to even create their own eval sets, they spend additional hour per trace that they create in order for them to understand how well that an agent might actually do in a particular scenario. And so we're starting to see that dealing with the evaluation problem is becoming near impossible when you're talking about agentic systems. And we're continuing to hear that this is an extremely unsolved problem. And if anything, it potentially is making it very challenging for agent native companies to actually succeed with the products that they're building. And so it's starting to become a really big blocker for the success that we're hoping agent companies can really achieve. And so the ways that we've really approached this is to really help companies be able to understand, interpret, explain, understand, and be able to even communicate the severity of the impact and of the failures that were actually caught, and to do this in a very very comprehensive research first type of way. And so. Given the taxonomy of what we've developed across these different kinds of failure modes, we're starting to see that different kinds of customers are starting to catch issues that they didn't even realize were issues. For example, this might be resource abuse issues, or instruction non-compliance with agents, or context handling issues. And sometimes these tend to be very nitty-gritty details. And so given the explosion of context and the amount of data companies are dealing with, it's no longer a problem of, hey, can I just track my data? But it's really, what can I do with it so I can ultimately understand where failures happen, and how can I automatically and systematically optimize and fix those issues as soon as possible. And so that's really what our vision is with Percival, especially as we start out here.
Yeah, that really helped a lot of it click for me. Like my kind of what I called my cursor moment with Percival was I put together a function calling agent that's using Weaviate's query agent as well as our async transformation agent, and I just kind of let it run, and it runs for a while. It does like 20 steps of function calls. This is like managing the data, and I can't be bothered to like look through it step by step, but I can just click generate insights with Percival, and now I think I just gained that insight into how the multi-agent system, because I can only imagine a group chat of all these agents, and it's just like I can't look through what just happened. Yeah, and
Right.
yeah, and it really is like maybe I want to explore this concept of like scaling test time compute, because now you have this tool to like, okay, I just scaled my test time compute like crazy. What happened with all that? Yeah.
Right, exactly. Yeah. Well, so I'd say the interesting thing about agents in particular, especially from a product or a customer perspective, is we've seen that companies are generally okay with agent workflows, running for longer, and we haven't seen latency actually become a big problem, mainly because we're seeing that the market is already kind of orienting itself around the idea that like agents are really good at being able to accomplish specific workflows. And so it's not really about can I have some kind of a lightning fast answer, but rather can I get something done? And so because of that, we're seeing that the latency piece is not too challenging. Of course, it means that the testing compute is larger, certainly, and that might mean more from a resourcing perspective, whether it's uh, memory or other kinds of infrastructure, whether it's model specific infrastructure or whatever it is. But apart from the, let's say, the resource consumption and the cost, we're seeing that at least from a market perspective, it's not too challenging, which means that in the world in which you do want to have, let's say, real time oversight and supervision, it's actually very much fine to introduce extra latency if it means that you can get the right kind of outcomes at the end of it. So I'd actually say that being able to leverage really powerful tools like Percival for real time supervision and oversight it wouldn't necessarily be a blocker for how companies orient themselves around what agents are really meant to accomplish today.
That's another question I wanted to ask you about Percival, is how you think about like with generate insights. If I just want like give me the quickest insight you compared to like do this deep research about all my agent traces, and then maybe that's how you think. Yeah, yeah,
Yeah, absolutely. So I'd say the way that we kind of evolved our roadmap for Percival was to start with the ability for you to have a one-click kind of experience to actually understand your trace, especially starting with single trace, and then we have also launched multi-trace analysis internally as well. And so that's something that we're really excited to be able to roll out very soon. And then the next version of this, which will also be introducing soon, is actually a very conversational experience through Percival Chat. And so being able to bring all of this into a super engaging and a very user friendly way for developers to be able to really just ask questions about all their traces, understand all the different kinds of failures that have happened, understand quick suggested prompt fixes, immediate fixes that they can make, be able to cluster the different kinds of categories of the impact of these kinds of failures, maybe even the ability to compare trace number one versus two versus three. There's a ton of flexibility that we want to really offer through a very conversational experience, and that's the kind of vision that we've had for Percival since we got started, because it really goes beyond just being able to see. Your data, but it's really to the next level of having an incredibly AI infused experience, just like you said, a cursor like experience to how you deal with building agentic systems.
yeah. And I especially talking about the multi-trace version of Percival, that I definitely am super excited about that. Like it kind of makes me think about this work around like AI scientists, and I mean, it's kind of like automating the job of like the agent engineer. Like maybe even we could take a step back and talk about one of the features of Percival, which is doing the prompt suggested prompt fix. And so that's already kind of, here's the intervention for how you're going to fix your agent. You can update the prompt, and now it's going multi-trace. It's analyzing all these things, and so I really feel like it's kind of evolving into the optimization platform as well. Like this will be how you tweak your agent as well.
Right, exactly. Yeah, I'd say that's also been a big part of our roadmap, is to be able to really have a really strong, let's say, flywheel to help companies be able to really close the whole feedback loop around what they're learning from how their systems perform and what they can do about it next. And so, what we've seen some of our early customers do with Percival is they'll be able to generate a lot of these insights, and they'll see the examples of suggested fixes to their system based on the failures that were caught. They'll actually take those suggestions and they'll put it back into Windsurf or into Cursor to then say, hey, like, can you fix this particular prompt based on this suggestion? And then they fix the prompt, and then they run it again through Percival, and then they see pretty quickly that, okay, actually this time it worked, and that this failure wasn't there anymore. And so that's a loop that we're really excited about. Companies being able to really figure out ways to streamline more quickly, especially as you're dealing with much more complex systems, like you mentioned, compound systems, and any kind of system with larger or more complex trajectories. We understand that the surface area of failures is only increasing, which means that having this kind of very, very powerful, fast feedback loop is extremely important. And so that's exactly what we want to be able to enable over time with things like Percival.
Yeah, that's so cool. And I guess I really just want to pick your brain further about the suggested prompt fix, and maybe just like yeah, like because you mentioned the idea of like you have your prompt and you're gonna like edit it with the suggestion, so it doesn't necessarily just pop in a new sentence of the some line to add to the prompt. Rather, it's going to try to like edit the whole thing, whether this is like a 3 paragraph prompt. Yeah, so maybe I just want to kind of zoom further into maybe like prompt versioning, maybe overall your state on that kind of prompt engineering perspective. Because personally, I'll say my sentiment is I still think prompt engineering is sort of I think RL is hot right now, and it's had a great like last couple of weeks, but I still think probably it's like a series of prompts. So yeah, I guess I just want to know about how you think about that, like prompt engineering and the state of that.
Yeah, absolutely. I think when things when the generative AI era really started in 2023, I remember there was a ton of a ton of conversation around why prompt engineering is important, and there's this new prompt engineer job description in terms of it was sort of like an art as much as it's a science, and so I'd say it's certainly still the case for every company that we work with, which is the challenge of the whole reason why one of the biggest reasons why you even need to think about evals at all is anytime you change a particular prompt, that just might result in something that it's sort of like a whack-a-mole problem where something else fails, and it's just you fix something here and then it fails somewhere else. And so how do you really make sure that you can comprehensively cover all the cases is still a hard problem. And so I'd say certainly agree that is something that we're also very cognizant of. And so in our product, apart from Percival, we have very different kinds of capabilities related to prompt versioning and experimentation, and being able to really manage this entire process from end to end, because we see evaluation is really not a one size fits all problem, and it is very much a workflow. It's not a point in time type of solution either. And so we want to make sure that all those kinds of problems are really solvable through our product. And so Percival is interesting in that it actually fits into that whole workflow, because it actually helps you be able to identify possible suggestions to the fixes themselves. And so the reason why it's also a suggestion is in some cases, there's potentially a larger space of possible things you can do to address a potential suggestion. And so it kind of also depends on the domain ultimately of what the developer or the team might have the most information on. And so wanted to start off by testing this in a way where developers have a lot more flexibility to approach the suggestion in whichever way they prefer, as opposed to getting kind of let's say an immediate prompt fix that may not actually work, and they have to kind of keep redoing it over and over. So that's a kind of a product experience that we may iterate on over time, especially as we get more feedback from customers as they use Percival. But that's how we wanted to start off in terms of the first version.
Yeah, it's so cool, and it really inspires me. Like one thing I learned from studying Patronus was I really like how you present links, the hallucination detection model, and you point out these like kind of like model features. I think it's like eight or so features. You kind of break down like the features of like what do you expect a hallucination detection model to do? What are the particular kinds of things that it does? And this is also something that we've already started to use at Weaviate. Take the inspiration is you break down our inferences into yeah, like the different capabilities of it, and then yeah, you might fix this one feature but you've cost the other ones, and that's kind of I guess the tricky thing about that multi-dimensional like radar plot of model capability. Yeah, it's
Mhm.
definitely a cool thing. It maybe inspires me, like maybe even just broadly talking about LLM as judge, and if we could just maybe transition a little bit into this broad topic around LLM as judge. Yeah, I think there's just it's just evolved so much. Obviously, Percival, this kind of like agentic LLM as judge, is like maybe it's the most advanced version I've seen of it. I've seen also some really cool ideas from like Haze Labs and Verdict. They have these like compound AI systems for judges, and yeah, I guess we could just maybe talk about things like rubrics and just ensemble inferences, maybe debates between LLM judges. That's my favorite idea, is where the LLM judges like will argue, like if you're rating an answer on a scale of 1 to 5, and they'll each take a position of 1, 2, 3, 4, 5, and it's like group chat to have some decision on what the rating is going to be. Yeah, I guess maybe I just want to kind of transitioning before I want to talk about links and a glider. I just want to kind of maybe ask broadly about what your experience has been just being in the space of like kind of like LLM as judge. And yeah, and I love that scalable oversight phrase, by the way. That's that's awesome.
Yeah, definitely. Yeah, so I'd say Elm as a Judge has been a really big part of our product for some time, and I'd say we were the first company to actually really productionize an Elm as a Judge approach, and of course supporting that through our API. And as a part of a lot of this work, like you mentioned, we've also published research in these areas, and so one example of an LM Judge that we had open sourced, like you mentioned, was Links from the end of last summer, and this was a state of the art RAG evaluation model for measuring groundedness in outputs. And what was neat about how we actually approached links was it was the very first time that someone had trained an evaluation model with chain of thought data. And so, in particular, it was chain of thought reasoning data that was semantically perturbed across a variety of different kinds of practical domains and use cases. And so, we wanted to make sure that it worked really well, especially on real world use cases like medicine and financial services. And so uh, when we developed that, a lot of that was in response to the fact that a lot of companies, whether it was that point in 2024 or today, that are all developing RAG applications, and we've continued to see that RAG is really the biggest use case that enterprises are developing because everyone wants to make sure that that the AI products and systems they're building have the right kind of context from internal teams and how they approach their own particular domain. And so what we continue to hear was that Elm as a judge is really really important, and some companies have started to try to use models like even GPT-4 to be like a general purpose evaluator. But we kept hearing a lot of different concerns around cost and scalability, but really around the performance of the LM, the performance of using GPT-4 as a judge. And so we thought, why don't we actually design a new model that is, in particular, specifically designed to be an LM judge? That's what really started everything that we did with links for RAG systems, and then we continued that with Glider as well later in the year, where Glider was the first SLM judge to be GPT-4o Mini, and the keyword there is SLM because we wanted to enable even more scalable use cases for things like this, so they can really effectively uh, be used as guardrails for real time applications. And so both of those were things that we really excited about and really enjoyed the open source traction that both of them got. And now, of course, our next phase of scalable oversight, Percival is what we continue to believe is really a really big part of how we enable this, especially for companies that are building agentic systems. And so
Yes, sorry.
I know you also had some other questions around how we approach different kinds of let's say newer kind of innovative evaluation concepts like different types of scoring and judge debates. So I'd say I have a lot of thoughts on this and can certainly share and can certainly talk a lot about where we see the most happening and where are some of the areas where I don't really believe it's there today, but perhaps will be there in the future. So I'd say maybe to start with rubric scoring. So actually, Glider in particular was actually has rubric scoring and multi-metric evaluation, and I'd say that generally I'd say it's really difficult for models to do ranking tasks and fine grained scoring, and so it's pretty valuable for users to be able to really specify detailed criteria. And so that's really how rubric scoring can really work. And so we have methods like that we support in Patronus as well. And then also, there's this question around, what is how do we think about like static scoring versus preference ranking, for example. And so I'd say what we typically seen as pairwise preferences are more helpful in either development or more open domain or generative types of use cases where there's no kind of specific task outcome to really achieve. But I'd say for more task oriented settings, like let's say booking a flight, like the example we talked about earlier, I'd say static scoring tends to be a lot better. And the other problem with pairwise preferences is that it sometimes is not really reproducible, and also can be actually sometimes pretty expensive for a team to do with batch human annotations. On the flip side, static scoring can sometimes be cheaper. And so, then I think in lieu of that, of course, there's LM judges, which although sometimes the downside is sometimes they can be non-deterministic, depending on how you're using the LM judges and things like that. And so I'd say that the space of the different kinds of approaches have really evolved, and I'd say it's not a one-size-fits-all problem, but we've seen some of the best serious and ambitious AI teams do really, really well with even some of these newer methods, especially even some of the most new methods around LM-as-Judge. And then I'd say with LM-Judge debates, I'd say I haven't seen these in production yet or teams kind of really using it. I think it's certainly more of an academic concept at this point, but a really interesting one. I'd say it's certainly one, especially in let's say higher latency use cases, can be really important, and also really important for highly regulated use cases where the cost of an error is really high. And so I'm really excited about the potential for where this can play a role in practical applications in the future. The challenge today is that there is a lot of course, there's also bias with using foundation models as judges, and so sometimes we've seen folks try to use foundation models in debates as kind of LM judges. And the problem is that if all those foundation models are all coming from the same training distribution, which is the case most of the time, it means that they are all biased toward each other. And so, in order for LM judge debates to really work well, my belief is that it has to be among judges that were trained and designed in nature to be LM judges. Ideally, those judges don't have overlapping training distribution. And so I expect over time, as more companies invest in this area, that's where the field will head.
Yeah, amazing. So many interesting ideas. I guess maybe just like parsing out some quick takeaways for me. I really like this kind of separation of like LLM as judge. We're using it to develop a system or version systems or measure your interventions, like changing the prompt, or you've done the latest GRPO to your model and how's it working. And then there's kind of like using it in guardrails. Like if the AI system is to give me a medical diagnosis, I would like them to debate all like please take as much time as you need for the inference and have this extra layer on assessing candidate output. So yeah, I really like that angle to it. Yeah, the rubric scoring, different dimensions, and then mentioning ranking is hard. I come Weaviate. We come from the world of search, and there's a lot of about how like NDCG trying to optimize that ranking thing. It's so much harder than you realize. So much harder than just kind of like recall testing. So definitely a deep thing to like uh, train models for ranking compared to like maybe like classification accuracy. It's just a much deeper task. Um, yeah, so I guess maybe I wanted to. I guess there was. I guess maybe just to finish out this, like just all of the LM judge topics I've kind of come across. There's one other called LM unit, which is kind of like instead of having evals for like a fixed set of evals, like kind of like a task perspective, it's like per instance. So like you take your instance, like maybe your question is like how does HNSW work, and then the judge generates all these different criteria like per instance. That maybe just be like the last whole topic. Just if I can pick your brain about like every LLM-as-Judge topic I've come across.
Right. Exactly. Yeah. Yeah. I'd say that's. I'd say it's a great approach, and really like what contextual AI did with LM Unit, and I'd say that that's also generally what we've started to see, especially as we work the market, started to hear about, which is in a lot of cases, AI teams are not even sure how to even really define the criteria, how to even really set up the evals to begin with, because they're not really sure what they're really optimizing for, what goals are they really trying to achieve. And so being able to leverage techniques where that process is easier to understand and easier to define upfront can be a pretty good way of approaching it from a framework perspective. And so I actually expect that as we shift into like we talked about earlier around dynamic evaluation, that this is going to be a key part of that entire system, which is agents are actually defining on the fly what specific kinds of metrics and criteria are really necessary to be evaluated while an environment or a system is live, let's say. And that could be something that, like you mentioned, uh, is really important for an instance by instance basis, because in a lot of cases, perhaps you may have very, very different kinds of users or customers, and they may have different kinds of needs. And so being able to define that much more in real time and having an intelligent solution to be able to do that is a very important approach. And so we at Patronus really liked what they've done with being able to innovate in that area as well.
Yeah, and sorry if this is a bit random. Just like something that popped into my head as I'm listening and like learning about all these things is something that I recently like. Sequoia just put together a bunch of AI talks, and I really like Harrison Chase from LangChain. He's always had a lot of great ideas, and his latest one is about the agent inbox. And sorry, this is pivoting a bit, but I'm just trying to like digest all these ideas. So an old topic, I guess, of just popping it back up. But I think about like Percival as it's going through the trace and it's trying to learn about the domain, and it's maybe doing this offline, like the multi-trace Percival, and then maybe it's doing this agent inbox, like to me, like, hey Connor, developer of the query agent, I have these questions for you about what you're trying to do. Yeah, sorry if that's a bit pivoting topics, but yeah, what do you think about that kind of interface?
Yeah, definitely, definitely. Your question is how would a query agent be able to deal with a problem like this?
Oh, sorry. So my question is like, yeah. So my question is like about so back to coming back to Percival, the agent that's kind of helping me build my agent, and then also that kind of like multi-trace perspective where it's like looking at a bunch of logs offline. It's like really looking through a ton of my inferences, learning, and now it's trying to like learn about it. And so I'm curious at like how you might interface interactions between like Percival and then me in that offline sense where it's like going human in the loop, like, okay, time to interrupt. Connor, I have these questions for you about the query agent.
Right, right, right. Definitely, yeah. I'd say that's a great idea in terms of uh, how a developer or an AI team can ultimately interact with Percival. Because in a lot of cases, especially if Percival is, let's say, dealing with really long trace data and potentially even in a real time setting, you may want to interrupt the flow and be able to guide it in a particular direction. And I'd say the human in the loop aspect is a really important piece of all of this. And so one of the things that Rebecca, my co-founder, when we first started the company, what's interesting is that what we had been brainstorming and what we were really excited about was this concept of critique assistant models. And so I'd say that's what ultimately LM judges to some level became in terms of how we evolved. But critique assistant models are a really great way of being able to do exactly this, but also loop in humans to be able uh, to guide them as they go through the process. And so ultimately, the end outcome is what we really want to achieve. And so if Percival can collaborate with humans in the right way at the right points in time to be able to accomplish that end outcome, then that's ultimately optimal for how we see scalable oversight. Because scalable oversight is not, it's not really about will AI replace humans, but it's really about how can we live in a world where humans coexist with AI, but at the same time, are not able to scale in the same way that AI can scale when it comes to oversight over AI. And so that's why we just fundamentally believe that human in the loop, regardless of where it fits in, is really important to our vision here.
Yeah, it's so cool. Really interesting ideas, and yeah, I think this is a transition a bit into. So, Anand, as I was kind of studying your background a bit and researching for the podcast, I saw that you had this background in causal inference, and so I really do want to talk about this a bit because causal inference to me is just one of these like really interesting areas of statistics that I feel like has like just so much potential, and I think especially this kind of thing of like intervention control. How do I fix the agent? I wanted to kind of zoom into this a bit and ask you about like your experience with that and how that guides your thinking.
Yeah, absolutely. I'd say causal inference was one of my most favorite subjects in statistics, especially because it was. I've always thought it's a great way to really estimate or predict why something really happened, especially in scenarios where it's really hard or very impractical to actually run a real randomized controlled trial or a real experiment like an A/B test. And so this is actually one of the main things that I really helped to push forward at Meta, especially specifically observational causal inference, including things like propensity score matching to be able to predict different kinds of impacts and effects that are really hard to predict in or impossible to predict in typical types of experimental scenarios. And so the challenge with causal inference sometimes is that there's a lot of assumptions that you're really making, and so sometimes you can't really trust the results that you see with causal inference. And so what really got me excited about the kinds of things that we're doing with Patronus is, of course, the fact that you can really see the impact of the ability to pinpoint failures and to really be able to explain the failures that's happening with AI products. And because it's a real kind of like real ground truth evidence of something happening, it's very easy to at least be able to help companies be able to scale their products in a much more rigorous and more accurate way. And so the way that I see causal inference playing into what we do in the future is to continue to make all of the methods that we bring to customers be a ton more rigorous, quantitative, explanatory, and most of all truthful to what's actually happening. And so that's what I'm really excited about. Where this may go, just in terms of this next phase of evaluation and observability toward supervision and oversight.
Yeah, it's amazing. It's definitely something that makes me excited about the future of Patronus. Is I think yeah, unifying these kind of ideas can make for such an interesting thing. I mean, I guess my question would be these LLM-as-Judge models that produce reasoning traces. How do you think about kind of like reasoning and then like a structured causal graph? Like, because I have a poor understanding of causal inference. I should set it up by saying that. But like, I understand it's like you have an interaction effect between variables. Like, if you're saying this prompt, like say this one sentence of the prompt, you think it causes this particular model feature. Like if maybe we have like 8 sentences of prompts and we think each one is creating one of our 8 model features, something like that. And then we're saying like if we tweak it, we expect it to lose this feature by this much. Or is that maybe the right way of thinking about it? Or yeah.
Yeah, absolutely. I think that's a great way of thinking about it. I'd say that in some ways actually extends more into model interpretability and less, let's say, kind of the empirical approach to being able to test models. And I'd say both are ultimately very, very important. I'd say from a customer perspective, we see more companies struggle with this problem space around the system layer, like on the, let's say, the RAG layer or the agentic layer, and less on the model specific layer itself. But I would certainly say that it's an important piece of even how we think about, for example, evaluation models that we've trained, like links. So, for example, one way to approach this problem is to actually train SAEs, sparse autoencoders, on guardrail models like links. And what you can then do is you can then get, of course, like a set of human interpretable features on the model itself. And then you can actually give customers the tools to adjust the sensitivity of these models. And that's actually something that I expect the space to evolve in over the next several months, just across the industry. In that today, not a single company, and maybe this is an idea for someone out there, but no one has actually ever trained sparse autoencoders on evaluation or guardrail models. And this would actually be a very important thing to do, especially if you're planning to run these kinds of models in production that happen to be and should be very domain specific. So I'd say using sparse autoencoders is one way of being able to really pinpoint interpretable features that can then actually give you uh, real tools to be able to adjust sensitivity in the right way.
Oh, that's amazing. And I'm almost like, I don't want to give up too much of what we're working on at Weaviate, but that we are kind of researching this idea of like interpretable embeddings, and particularly kind of taking like a classification perspective where we have all these different axes of classification labels to come up with like, say, a 5-dimensional vector, each with cardinality, say 10. And then you have like this really interpretable retrieval through classification is, I think that that role of like classifiers integrated with document labeling, yeah, and creating this interpretability aspect of it. Yeah, all that is really amazing. So awesome, Anand. I'd love to kind of maybe pivot back into the Patronus platform and kind of the product that you're developing, as well as our partnership with Weaviate, and maybe discuss some things about like the data infrastructure requirements, maybe how vector search can help, and all these kind of things.
Yeah, absolutely. Well, I'd say the one of the key parts of how we built Percival was with Weaviate at its core, especially because of the memory component. I mentioned earlier that one of the big problems that we continue to be very focused on is how do we really make uh, evaluation and oversight very domain adaptive. And so, one of the things that we've started to see a lot of AI teams do is to, of course, predefine their own evals and write their own unit tests. Sometimes it's quality check, sometimes they try to use LLM-as-Judge or something else that can work. Uh, but especially as we enter into a world where things are a lot more dynamic and a lot and scalable evaluation is very much necessary. That means that the ability for evaluation to be very domain adaptive is really necessary. And so in order for that to be possible, of course, how we approach memory is a key part of that. And so we were able to work with Weaviate to be able to do exactly this in terms of implementing things like episodic memory and semantic memory to help make sure that Percival is actually very domain adaptive to how customers are developing their own AI systems. And so the smarter and the more intelligent Percival is to your own domain, of course, the more effective it will be. And so, without being able to approach memory in a very rigorous way, Percival would not be possible. And so that's how I describe, how what this means for us and where we see that going for the future.
Amazing. So I'd love to just immediately double click on how you separate memory into, yeah, episodic and semantic memory. Could we just kind of zoom further into that?
Yeah, definitely. So episodic memory is referring to memory about past instances. It could be past user interactions. It could be any kind of information or context about things during the lifetime of, let's say in this case, Percival. And then semantic memory is more about the baseline. It's more about the ground truth, facts, knowledge, evidence about that particular domain that you're really seeding the information with. And so ultimately, both kinds of memory are really important. And I'd say that ultimately it's important not just for the lifetime of an overall AI product, but even within a particular trace. And so both of those kinds of things are the kinds of things that we're going to continue to develop over time.
Yeah, amazing. If I could just kind of be like a database nerd a little bit, when you think about the database schema for designing this memory, do you just have, say, like one collection with two properties, each with a vector index, or like, full search, full vector and full text search for like episodic and semantic memory? And is that just, and then you just kind of like scale that out like per tenant? Is that kind of like the database view of that particular memory design?
Yeah, I'd say so. Yeah, I'd say the way that we, for example, approach it is we had a Weaviate collection, and within that we would be, for example, saving memory as in separate objects as vectors, using I think the text to vectorizer, and then we'd be saving additional properties related to those entries, and then when, for example, there's specific runs, we'd be thinking about how do we really search for the closest ones in that space. And so that's generally how at a high level we really approach memory itself. And of course, all of this is especially possible because of how we were leveraging Weaviate for this.
That's so cool. And I think I don't want to ask too many questions about how the secret sauce is made, but I'm so curious about like metadata and the kind of vector database schemas and kind of a lot of the talk about things like, the lack of the kind of, because like vector databases are kind of designed for like the first case of it, like when the original RAG paper came out, I think a lot of researchers was like, yeah, we're going to vector search with a billion we're going to put all the scientific papers in one big index. And then as it evolved, it had more of this like multi-tenant pattern where it's like, no, we have a million users, each one with like a variable amount of documents. And then now I think we're seeing more metadata in the kind of like vector data model, if you will. And yeah, so I think definitely something for us to talk about later. But I'd love to anchor the podcast on with this topic of what future directions for AI excite you the most.
Yeah, absolutely. Well, I'd say I'm really excited about a lot of things that are coming up in general in terms of what a lot of different kinds of folks are working on. Apart from, of course, what we have coming out in the next several months, I'm really excited about emerging architectures. Of course, beyond autoregressive models, like for example, state space models has been something I've been excited about for some time, and generally the ability to be able to to leverage different and new kinds of information is something we're really excited about. I'm also really excited about different kinds of synthetic data generation capabilities, especially in the ways that it can help not just train new models, but even help to understand how models work, both from interpretability perspective and also from an evaluation perspective. And so really, really excited about that. And then, on that note, really also generally very excited about model editing as a subset of
Wow.
things around model interpretability. And I'd say it goes hand in hand, kind of adjacently with scalable oversight. And so really excited about where all of that is going to the future, and just fundamentally believe that these are some of the most urgent problems to be solved, especially on the path toward AGI.
Yeah, I guess the model editing one to me is, I guess I'm so like trying to hold out on the prompt engineering because I feel like the operational overhead of changing the weights of the model is such a pain that if I could instead just, if there's just a way to instead get all the domain information, everything we need into the prompt, and then also kind of like the decomposition of inferences, if that's the approach. So maybe those three are each great topics, but maybe we could start with that one. And I do want to ask you one more question about synthetic data generation. But yeah, talking about model editing, just yeah, what's your sentiment on that kind of operational overhead of actually changing the neural network itself?
Yeah, absolutely. I'd say it's. I think I'd say it's very much still an unsolved problem, but a very important problem in generally mechanistic interpretability to understand exactly how that can work. And I'd say things like sparse autoencoders are really great in being able to help us really solve that problem. But it's also very finicky and very hard to get these right ultimately. And so I'd say the probably the biggest conundrum or contradiction of today's day and age is we have extremely powerful, large, very, very large probabilistic machines that we don't really fully understand in terms of how they work. And so it very much in many ways is sort of like the human brain. And so really excited about, where the research around model editing and interpretability will really lead to. And very excited about companies like Goodfire that are paving the path for things like this.
That's awesome. I'll definitely be looking at the good fire later. It sounds really love to just know what's happening. I remember there was like Rome and like Mehmet. Oh, I've already forgotten the names of the papers, but yeah, definitely like parametric knowledge conflicts is something that I think is big for people working in the RAG space. Awesome. So then I also want to click on that second one about synthetic data generation because kind of like we're researching new agents we might develop at Weaviate, and something that's really interesting is maybe something that helps you create objects. In particular, I think about creating eval sets, and I think about maybe this like deduplication is the interesting thing. So you start out with the same prompt, like this is the agent, these are the inputs and outputs, this is its prompt, you're supposed to be testing it, and it's just like generating cases. And now like the system thing is to like deduplicate it or explore new directions. There's a lot of interesting work from like Jeff Clune and Kenneth Stanley about like quality diversity algorithms, and yeah, maybe just like yeah, synthetic data generation. What kind of interesting things are you seeing around that?
Yeah, absolutely. Well, I'd say what's becoming more interesting, especially with synthetic data generation, is the ability to actually leverage agents to actually to do this. Initially, it started with let's use an LLM, let's prompt an LLM to create some new data, but now with agents, you can actually of course, add in a number of different kind of steps to that workflow, whether you're calling different tools or APIs, whether you are dealing with internal documents you want to be able to ingest in a RAG workflow. And all of a sudden, you can now generate some really, really high quality, very specific, data that's very specific to your domain that also contains a lot of diversity in the information. And so that's from one perspective. That's just about how can we just generate data a lot more quickly. But then there's this idea of is there ability to generate adversarial data sets as well with agents. And so I'd say adversarial data generation is also another area that is similar, but also one that I'm very excited about, especially because it allows us to make it more systematically possible to actually comprehensively test different kinds of systems. And ultimately, when it comes to evaluation, the data piece is half the equation. And so any new research in that area that involves doing this in a much more systematic but more high quality way is something I'm very excited about.
Yeah, amazing. I like that like adversarial. Like I'm really interested in it for creativity. Like something I lost a ton of time in is when ChatGPT got really good at images. I was creating these like gorillas that would have like a Weaviate branding on them. I just became fascinated with the question of like how many of these gorillas can ChatGPT come up with?
Yeah,
And yeah, that's how I
exactly.
kind of lost myself in that type of thinking. Anand, thank you so much for joining the Weaviate podcast. It's been incredible learning all about all these things from you and your team at Patronus. I'm so excited about our partnership with Patronus and Weaviate. And to everyone listening, I highly recommend checking out Percival. It is such a cool experience. It's so much fun. And I mean, I really enjoyed it. And I just couldn't recommend it enough. Anand, thank you so much.
Thanks so much for having me, Connor. This was an amazing conversation.